You're listening to a special AI-powered training session generated based on my original research and training documents. While the voices you are about to hear are AI-generated, the insights come directly from my verified material.
Welcome to the Epoch Zero Show. Today we are unpacking Module 1.3.3, Transformer Era and Foundation Models, 2017 to 2022. So, before 2017, AI had a fundamental problem. Our models, they were stuck in a line. They had to process language one word at a time, just like you'd read a book. Think of RNNs. This created a massive bottleneck. It was slow, and it was completely linear. The big unlock was a mechanism called self-attention, and it's a complete game changer. Imagine, instead of that slow, one-by-one process, the model can suddenly see the entire sentence at once. It weighs the importance of every word against every other word, simultaneously. This was the key that opened the door. And that brings us to the inflection point itself, the moment everything changed. A 2017 paper from Google, and the title really says it all. Attention is all you need. This paper gave us the transformer. And you have to understand, this wasn't an improvement, it was a replacement. The old sequential way of doing things was over. The benefits were, well, they were immediate and they were massive. Suddenly, training could be parallelized. We're talking 10 to 100 times faster. That's not an improvement, it's a phase change. The model could now finally connect the dots between words far apart in a document, solving that old, stubborn, long-range dependency problem. And the best part? The whole thing was built to scale from day one. Now, there's always a trade-off, right? And here it was compute. The complexity is O of n squared. That just means if your sentence length doubles, the compute needed quadruples. It gets expensive fast. And why? Well, because every single token has to attend to every other token. It was a known cost, and it was a price we were willing to pay. So with this powerful new architecture, the entire field kind of split right down the middle. It forked. Two different philosophies emerged on how to actually use the transformer. You either wanted to understand a language, or you wanted to generate it. On one side of the fork, in 2018, you had Google's BERT. This was an encoder-only model. You can think of it like a detective. It reads a sentence from both the beginning and the end at the same time to get the full context. Its job was basically to play fill in the blank to truly understand meaning. Then you had OpenAI's GPT, a decoder-only model. It was a storyteller. It only read from left to right, and its only goal was to predict the very next word. So you see, one was built to understand, the other to generate. And let me tell you, when it came to understanding, BERT was king. No question. It didn't just break the records on the GLU benchmark, it shattered them. That detective-style bidirectional approach gave it a kind of contextual awareness that was just unheard of at the time. The proof was in the pudding. And this leads us right into the next chapter of the story. The focus shifted. It wasn't just about clever architecture anymore. It became a bet, a big one. The new hypothesis was that just pure, brute force scale could unlock abilities we hadn't even imagined yet. Then in 2019, OpenAI drops GPT-2. We're talking 1.5 billion parameters. Now that's more than 10 times bigger than what came before it. This wasn't just another step up, it was a whole different league. And for the first time, we saw a model write entire paragraphs of text that actually made sense, that felt coherent. The power of scale was becoming very, very real. But the release itself was messy. OpenAI got nervous. They cited concerns about deepfake text and misinformation, so they held back the full 1.5 billion parameter model. Instead, they did this slow, staged release over 9 months. It created a huge debate. Some researchers called it AI safety theater. It was really the first time our industry had to have a serious public conversation about what responsible disclosure even means. And just when we thought things couldn't get bigger, 2020 happened. GPT-3 arrived. And the numbers are just staggering. 175 billion parameters. Let that sink in. This wasn't just another step. It was over 100 times larger than GPT-2. The scale was almost unbelievable. To train a beast like this took an insane amount of compute. We're talking 314 zettaflops. I mean, what is a zettaflop? It's a billion trillion calculations per second. It's a number that barely fits in your head. The cost ran into the millions. This was the great scaling bet taken to its absolute extreme. And boy, did that bet pay off. GPT-3 showed us something new, something that felt like magic, a capability we now call in-context learning.
What this means is you could just show it a few examples of a task in the prompt, and it would just learn on the fly. No retraining, no gradient updates. It learned from the context you gave it right then and there. A total game changer.
At this point, the whole industry was just intoxicated with scale. The mantra was simple: bigger is better, always bigger. But a course correction was coming. The next pivot wasn't about size. It was about being smarter. So everyone had to ask the big question: is bigger really always better? And as it turns out, the answer was a hard no.
You see, for a while, everyone was following OpenAI's Kaplan scaling laws. The idea was pretty simple. Performance just gets better and better the more compute and parameters you throw at it. That's what justified building these monster models. But then, in 2022, DeepMind published the Chinchilla paper, and it was a bombshell. They found that these huge models, they were all severely undertrained. It wasn't about having the most parameters. It was about the balance between your parameters and your data.
And the Chinchilla paper gave us a simple, elegant rule. A rule of thumb: for every one parameter in your model, you should have about 20 tokens of training data. That 20-to-1 ratio, that was the new formula for efficiency. It told leaders exactly how to build.
The proof was right there in the data. DeepMind built Chinchilla, a 70 billion parameter model, and they trained it on way more data. Following their new rule, what happened? For the exact same amount of compute, Chinchilla consistently beat their older, massive 280 billion parameter model, Gopher. The lesson couldn't be clearer. Smarter scaling beats bigger scaling.
Okay, that brings us to our final and maybe most interesting topic from this period. We're talking about emergence. These strange, unpredictable abilities that just appear once a model gets big enough.
I mean, things like multi-step reasoning, what we call chain of thought, just showed up out of nowhere in these bigger models. The ability to follow really complex instructions, even in-context learning itself, these were all emergent. And the debate is still raging today. Are these true phase transitions, kind of like water freezing into ice? Or are we just getting tricked by how we're measuring performance? Honestly, we still don't know for sure.
So, the key takeaway for any leader from this whole era is simple. At first, the race was just about building the biggest possible engine. But true maturity, that's knowing the right ratio of engine size to fuel. Efficiency became the name of the game.
When you look back on it, it's really a story in 3 acts. Act 1, the architectural unlock with the transformer. Act 2, the brute force bet on pure scale. And Act 3, the smart pivot to efficient optimization. That 3-act structure, that's the foundation for everything that's happening right now.